Alright, so it's time to do some silver plate. Get my goggles and my gloves on because this is going to be the dangerous stuff. We are working with sulfuric acid and nitric acid. So I've been mentioning this method here for quite some time. I've done it a little bit, but off camera, just to kind of test it. And then I did try it on camera with the relays. And I don't think my solution was quite right. Well, no, my solution was right. My relays, the contact percentage was not. So here we go. We're going to go ahead and dump a little bit of sulfuric in here. It's quite a bit. This stuff is really dangerous. So if you're contemplating this, please be careful. Alright, so we got sulfuric. And this thing with this stuff is, if you clean your beakers, you have to rinse all the water off. You have to make sure there's no water on your beaker. Another thing too is you never want to work with water around. So like this, no go. We're going to put that away. We don't want anything spilling in here. The good thing about this method is we don't have to add heat to it. Now we can add a little bit of heat. But if we go too much, just like in my previous video with the relays, if we add too much heat to sulfuric, it's actually going to start to dissolve the copper, which is what we're trying to avoid. So when I add nitric in here, we're just going to be targeting the silver. So let me get some nitric acid and pour some in there. Actually, I still have some from the other video. And we're going to go ahead and put around 50 milliliters of nitric in. There we go. And again, this stuff is dangerous, so let's, just be careful. Make sure you got your gloves on, your safety glasses, all that fun stuff. It produces a menacing vapor too. So, well ventilated area. You guys know how it works. All right. Now I gotta go grab some silver plate, and we're gonna go ahead and put that in there. Alright, so our first test here, and I think this stuff even ate my black pair of gloves. I think this sulfuric actually put a hole in those gloves. I think it was sitting on there for a little while, but nonetheless, we now have a hole, and I don't work with anything sharp, so I think the acid's got to it. So here we go, and it's not quite, dang. All right, I gotta find a different piece. All right, I'm back, got some goodies. So this isn't the only stuff that this liquid's gonna be into. And I know this is a lot, and it looks like a lot for this, but I'm gonna transfer this liquid into different shape apparatuses to fit different size and different shaped items. So, I'll put some of this in, let's see here, get some of the air out. I'll put some of that in, a graduated cylinder. Put some of that in smaller beakers. And you can kind of see the reaction right off the bat. Let's see here. I'm gonna put that one half and half, or not. We'll put this one half and half and see if that can stay. There we go. So then we can get a good look at that one when the nitric's done eating that up, and you should be able to clearly see the difference between the silver plated stuff and the non-silver plated stuff. And you can speed this up, like I said, a little bit if you add some heat to it, but I'm in no rush with this stuff just because I have so much of it to do. I'll just kind of let it do its thing, and we'll go from there. Alright, so this has only been in there for, I don't know, probably 45 seconds to a minute. And you can already see the difference here. We can see plenty of that brass compared to the top. So we're just targeting, and this solution should stay clear. It should say crystal clear. right, we can see that silver going into solution there. All right, there we go. Got a good example there. It's cut in half. Here, let me see here. Let me grab my gloves quick. Bring that up a little bit. I guarantee. See? Nothing but brass now. I'm just going to go ahead and rotate that. And I'm going to give these a little bit of a rotation here. We had a good example of some copper in there. If I can get it. Let's see here. So that's more brass. That's more brass. This guy right here, that's copper. So you can see it eats that up real well, really nice. So I do have to separate these guys though, because I want fresh acids eating silver. Nice. Those used to have silver on them. All right, we've been doing pretty good here with our silver stripping. Get my goggles and my gloves on here quick. See how that silver chloride is settled down. Let's see here. Start removing some of this stuff. I think that could go in for a little bit longer. See here. Let's say that's good. Let's say this is good. Rinse that off a little bit. Say this is good. Try to get all of the solution off of there. But the tap water that I introduced this stuff to is got chlorine in it. So we're going to make some silver chloride. This does a really nice job stripping this stuff. And all this brass, I'm going to go ahead and just trade it all in, take it down to the scrap yard. when all is said and done, I've got about 100 milliliters of nitric in here. So it's going to take a little while to get all this stuff off. Well, it'll take a while to get rid of, use all this nitric. But here's a good example. This was silver plated, some electrical scrap. So we got nice copper there now. I'm going to go ahead and turn this over. Another nice clean piece. I'm really not sure what this stuff is. I don't know if the silver is just coming off of there weird or what. Or if it's not silver at all. Because this has been sitting in there, I'd say, for overnight. The same amount of time this has. Alright, so I just dumped my my tweezers in that water, so they're not going to go back in there. So got a second pair out. So I don't know. I think I'm going to take these out. We'll see what happens. Alright, now it's time to introduce some more to this. And this will probably be a relatively quick video, which I'm okay with. Because I just wanted to show you how well this works. Because I showed you on the other one, that other, when I was attempting to do it with the contacts. But like I was saying, I don't think the... I think it has to be pretty close to pure silver in order for this method to work. So I mean, that could be silver there, but that could be closer to, like, you know, maybe not pure silver. I don't know, maybe sterling. I haven't tried it with sterling, so I don't know if that is pure enough to do this method. Maybe we could try that one of these days. But you can see that it works relatively quickly. So that's my only concern with those other pieces. They've been sitting in there overnight, and they haven't changed. So, or they have changed, but you know, I put those in the same time I did those electrical contacts. So, goes to show that we probably have something in there other than silver, or not as pure of silver as I would like it to be. So there we go. And I just want to add here, I don't know if we can see it there a little bit. If you look at the green beaker back there, you can see that vapor coming up now. So that's when we get reaction. So it stops when there isn't anything happening, right? So when I had those pieces in there, I wasn't getting any sort of fume. So I know that as soon as I introduce this, the reaction starts again, and we've got silver going into solution. So that's always good. All right, well, I'm looking here. Now this is my one that was in the water. Look at it. Now I'm confused. Now I am confused. Interesting. Maybe it just flaked off of there. Well, we're going to have a bunch of silver chloride at the bottom of this. There's no question about that. And you can tell that there's a little bit of nitric being involved too, because it's actually starting to pick up the copper. The copper is starting to go into solution. I also have a piece of sterling in there too, so when I introduce this, that hopefully we can eat some of that sterling up too. But I imagine because copper is more reactive, it's going to go after the copper first. And those will go right into the copper bin. And I will, I might keep some of those. We might use those as some anodes. See if we can purify them up just for fun. But I really think some of this is brass, and I don't know why. I don't know if the top layer of zinc gets eaten up first. So like here, I'll show you. And then it only shows the copper. Let me get my gloves back on here. I don't want to be reaching in there without any protection on that. Sulfuric really lets you know when you got some on your skin really quickly. So let's see here. So we can see that it's brass, right? I mean, and it doesn't take long without heat at all for this to get stripped. I mean, it goes relatively quickly. It's actually kind of a nice process. So if you look at that, it's all brass. And when I go and dip that inside the water, it'll actually all turn, my second set, it'll all turn copper colored. So like I know this was copper, and I know those electrical contacts were copper because I file tested those just to see if they were pure silver or not. Interesting. Very interesting. Well, we'll see. I don't know. Maybe they'll take it in as copper. I don't know how to go about that, because I don't want to trick anybody, you know, if that's what it is. But maybe they can do a test on it or something if they're curious about it. So just wanted to give you a quick update. That is all of the silver plate I've removed out of this entire solution so far. Hey guys. All right, so that worked out really well. Now I tried it with the contacts, so you can see that video. Let's see here. There we go. You can see that video, and it didn't work as well as this does. And now I think it's because of the actual content of the silver in contacts is too low. What I think is happening with the contacts is that you basically dissolve all the silver left, and then you have a layer of base metal where the nitric can't penetrate it then. And that's kind of what it looked like, because it would look like copper, and then once you would rinse it off, you would see the silver come back. So, but as you can see here, works excellent. So, you know, that's got to be close to, I would say at least sterling, you know, if not 3/9 fine silver when they played it, but I don't know. But it works really well. Comes right off of there. And, you know, it really only takes like 10-15 minutes for a piece to put in there with no heat. Yeah, I don't think it's worth heating up. I think you can heat it up a little bit and it goes a little faster, but I mean, 5-10 minutes, that's pretty quick. I mean, anyways, so I've got a couple of buckets left of this stuff. So this is going to take me a little while to consume all the nitric in that solution. But what I'm going to do is I'm going to add. Well, so I started in the biggest beaker I got, right? So I can get the biggest pieces in, and then what I'm going to do is when I'm working in smaller pieces now, I'll pour that into, like, let's say a 500 milliliter jug, or, you know, I think a tall form 1000 would actually be really nice. I think I'd get a lot because I think I've got 750 milliliters of fluid together. So if I dumped it in like a tall form 1000, I've got a couple of like cups that are a little bigger, taller, I should say. So that probably worked good, at least enough to dump it in and then, you know, flip it, get the bottom half. But we'll see. Or maybe I'll have it. I'll have enough to do the graduated cylinder and the beaker. I don't know. It's gonna be a. But anyways, I've worked from the biggest one to the smallest one because I'm gonna lose a little bit of solution as I go. Right. I mean, as you pull each piece off, some of it stays on the metal, some of it goes into the wash bucket, and you get silver chloride. You lose a little bit of solution, and then of course when you pour it off, you can't mix, right? You can't spray the insides of that stuff out into the next beaker because as soon as you add distilled water to it, you're going to start dissolving copper. So that's a no-go too. But yeah, I really like that method. It works really nice. It's just kind of time consuming because you really don't want to do it with a small batch, right? Because it takes quite a bit of this silver plated stuff to get really anything to, like, basically to make it worthwhile. So I might have this solution for a while. So I know I'm gonna have a part 2. We'll see how this does. If I've got, like I said, I'll put the pictures up. I'll do one here and second one here. And if those go good, and I still have nitrics left over, I'll just save that until I have, you know, more silver plate, until it's all gone, and then we'll go ahead and we'll do a part 2 of this video and get it out of there. Which I just bought a 5,000 milliliter beaker specifically for this project because you want to dilute this acid or the solution 2 to 1 at least with distilled water. So I just wanted to make sure we had enough space. Probably could have got away with a 3,000, but you know, I'm not a fan of the solution getting to the top of the beaker anymore. It's just too prone for disaster. And I'm done flirting with disaster. It's not as fun. Yeah. Well, thank you so much for watching this video, and I'll see you in the next one.